Greetings and welcome to this video course, Unreal Development Kit Game Programming with UnrealScript, presented by Pact Publishing. My name is Alan Thorne and I'll be your instructor on this course as we explore the basics of UnrealScript programming for games. If you've never used UnrealScript before, or if you're new to the UDK, or if you're simply looking for a solid foundation in UDK programming, then this is the course for you. We'll start by downloading and installing the required software, then we'll jump in and start coding, and by the end of the course we'll have completed a simple but instructive games. So let's get started. Okay, so what I'm going to do now to get started coding in UnrealScript is to download all of the necessary software. Now for this course we're going to be using three different programs. The first one that we're going to use is the UDK itself. So I want you to go ahead and download that if you have not downloaded it already. You will see here that I'm using the February 2013 version, which is the latest version at the time of recording this course. If you have a later version available to you, then go ahead and download that, and all of the code for this course should work absolutely fine. Now the UDK does not come with a code editor or any kind of text editor for typing in UnrealScript commands. To do that, we're going to have to use a third-party editor, and the editor I have chosen is Notepad++. If I bring up this second tab in the web browser, you will see we have Notepad++, and it's at notepad++.org. So I suggest going ahead and downloading that editor there, and we can type in all of our UnrealScript commands. Now the third program I'm going to be using is UncodeX. If I switch over to this tab here, this program is optional. It is not compulsory. You do not need to download it if you do not want to, but I recommend that you do so. Using this program, we'll be able to examine and explore all of the UnrealScript classes and objects that are available to us in script. It will act as a class browser. So there we have it, those three programs. I'm going to go ahead and download and install all of those to my computer, and all of these are freely available programs. You don't need to pay anything for them, and once installed on your computer, we are ready to get started with UnrealScript. So now I have successfully installed the UDK to my system, and before I do anything else, the first thing I recommend you do is to run the UDK editor at least once. This is important because doing this will cause the UDK editor to generate script files and settings files. So I'm going to double click on this file here, the UDK editor, to load the editor. We see the loading screen here. And doing this will ensure that we get a whole series of files generated, and it's useful to have these files on our system when we are working with UnrealScript. So there we have it. I've just loaded the UDK editor. This is its default arrangement, and that's all we needed to do. Now that we've done that, we can just close the editor, and I want to just take a look over the files and folders that are installed by the UDK, and to give you a quick rundown on what they do and how they relate to UnrealScript programming. Okay, so the UDK installs itself onto your computer and creates a set of folders. I have installed my UDK here to DUDK. You don't have to install it there, you could install it elsewhere. It has created a folder UDK 2013-02. For you, the date might be different if you're using an earlier or a later version. I'm going to open up that folder, and you can see we have four main folders here. Now the binaries folder, that is where it installs all of the editor applications, all of the binary data, all of the stuff that it needs for the editor. So we don't really need to concern ourselves with this folder. It's not relevant to scripting. The engine folder also is not especially relevant. This contains all kinds of configuration data and other resources that's used by the Unreal Engine component, which is the main part of the UDK, but again, we don't need to make changes to any of these files when we are scripting. The UDK game folder is for game-specific data. So if we're an artist making meshes, graphics and textures, we'll need to use the UDK game folder to house all of our assets here. Where there is the script folder, this is where we'll keep all of the compiled script files. The UDK will handle all of this automatically using its compiler. it will save all of the compiled script files in this script folder. But again, we don't need to worry too much about this folder. We'll come back to it later. The key folder is the development folder. This is where the magic happens. Let's double click on development here, and in the src for source directory, this is where we will find all of our UnrealScript source code. There's all kinds of folders and files in here. These are all script files that come with the UDK. So I just want to quickly mention that all of these source files in the development source folder that come with the UDK, don't go ahead and change any of these. Just leave these as they are. That way the original code is always there. When we create our own code, we're going to be building classes that will extend from these. So you can go ahead and examine all of these files and folders and take a look at the script that comes with the UDK. We can leave all of this for now. When we create our own script files, just know that we'll be creating them in the development source directory. We cannot create script files anywhere else. They must be in the development source directory. So just keep that in mind. Now I want to have a look at UncodeX, which is one of the applications that we downloaded at the beginning of this course. This program will act like a class browser, allowing us to view all of the source code and objects in the development source folder. The first time you run UncodeX, you will be presented with this settings dialog, and make sure in this settings dialog in source paths that you add the path development source, the development source folder in the UDK directory. So click the add button and choose that path and then click OK. When you do that, UncodeX may run away on its own and generate a class view here. It may not, and we have to do it manually. Click on Tree and Rebuild and Analyze, or press Ctrl B on the keyboard. When you do that, UncodeX will run away and begin to generate a tree on the basis of the script in the development source folder. So I'm going to click OK there, and you can see that we have a whole range of data that's populated in this view. Now in this leftmost panel, we can see the different modules that we have. We have core, engine, game framework, and others. If I bring up the development source folder for the UDK, you can see that this panel here mirrors the folder structure that we have in the development sources folder. So we have core here and core there, engine and engine, and so on and so forth. Now each of these modules contain a whole range of different classes, and these are listed in this second panel here. For example, we have the actor class. If I select the actor class, I can see in this rightmost panel the source code inside that folder, inside that file, beg your pardon, and you can see the file listed here in actor.uc. So if I bring up the development sources folder and I take a look in the engine folder here and the classes subfolder, I can see I have actor.uc, which is the source file for the actor class. All UnrealScript source files end with the extension .uc, and each file here, each of these class files, is a separate class. One class per file. So if you wanted to go ahead and create your own classes, you would move back to the development sources folder. You would create a new folder inside here, and you could name that whatever you want. That would be the name of your module. So let's take the core module. We can open up that, and inside here we would have a classes subfolder. Whenever you create your own folders in the development source file, you must ensure that you create your own classes subfolder, and all of your classes must be in there. So development source, the name of your module, and then a classes subfolder, and all your classes should be in there. We're going to see this in action shortly. So the next program I want to consider is Notepad++, which is the third program that we downloaded and is the text editor where we are going to be spending a lot of time typing instructions in UnrealScript. We're going to be using this effectively as an IDE, an integrated development environment. And to get this up and running, we need to configure it. Now, there are several things we're going to need to do, but the first thing I want to show you is syntax highlighting. Let me just demonstrate what the problem that we face is. I'm just going to bring up the development source folder here into view. And here we have the development source folder that is part of the UDK. Let's open up, for example, the engine folder and then classes, and let's double click on actor.uc to open up that file into Notepad++. And you will see the first problem we have is that all of the text, all of the script here looks exactly the same. There's no difference in highlighting or formatting that will help us when we are coding. We could use it like this. We could start typing in code here, and that would work absolutely fine, but it really can make our lives a lot easier if we can get some syntax highlighting in here, just so that we can help visualize and see the code much better. Now, to do that, I'm going to bring in a Firefox window because a user of the UDK community has very kindly, a man named Doug Clayton, he has very kindly created an UnrealScript highlighter for Notepad++. So you can search Google for UnrealScript Notepad++, and you will get to this thread where you'll find his UnrealScript highlighter. So just click on that link and download his UnrealScript highlighter. That is an XML file. And now I'm going to jump back into Notepad++ to show you how you can import that XML file and configure the editor. Okay, so I am back here in Notepad++, and we have our actor.uc class available, and you can see that we still haven't got our syntax highlighting. But we can fix that by importing the XML file, which has the syntax highlighting for UnrealScript. Now, to do that, I'm going to choose Language, and we can move down to where it says Define Your Language. And I'm going to select that option, and this window appears here. The bottom of this window moves off outside the recording window, but that's okay. We're going to be using these buttons up here. So I'm going to click the Import button, and from this open dialog, I'm just going to move to the UDK folder and choose my UnrealScript XML file. Now, your XML file may be in a different location depending on where you downloaded it, but I downloaded mine here, so I'm going to select this UnrealScript XML file like so. It says import successful, so that all works absolutely fine. I'm just going to close this window now. That's all we needed to do. And you will see, there's still no syntax highlighting at all. So what we have to do is just close Notepad++, and we can open Notepad again. So restart Notepad, and this time select Language and select UnrealScript from the menu. When I select this, all of a sudden our code now has syntax highlighting, and this highlighting will be applied by default when we open our UC UnrealScript files. So now the source file is looking much better. We can see all the commands much more clearly, and that is how to go about getting syntax highlighting working in Notepad++. And one thing I just will add in closing here is that the UDN, the Unreal Developer Network, and the UDK forums are an online place where you can go to find not just the syntax highlighter that we've used here, but any kinds of information about the UDK. So if you're stuck on a problem and you can't find the solution and you want to see if you can find it online, then the forums really are just a fantastic place to start. I thoroughly recommend using them. Okay, so what I want to do here is show you how you can recompile the UnrealScript source code. Now, at the moment, we haven't coded any classes ourselves, but the UDK comes with a lot of pre-made source files that can be found in the development source folder. So what I want to show you here is how you can recompile all of that source code. Now, there are really two main ways to go about doing this, the manual method and the automatic method, and I'm going to show you both. So first, let's start with the manual method. What I have in front of me here is a command prompt window. I'm in the UDK binaries Win64 folder. I can also be in the Win32 folder. It doesn't really matter. The 64-bit version just uses the 64-bit compiler. Now, before I go further and type in any instructions at all, I just want to quickly show you how I can get this command prompt window open in front of us on the screen. To do that, I'm just going to jump back to the Windows desktop. So here at the Windows desktop, the manual way to open the command prompt window, we can start by pressing the Windows key and the R key on the keyboard. So I press Windows key and R, and when I do this, it displays the run dialog that we have here. We can type in the command CMD for command and press OK here, And when I do this, we get the command window appear, and you can see that it begins here in the user's Alan folder. For you, it will be a different folder, but no matter what folder it is, it will not be the UDK folder. Now, of course, we can get to that folder by typing some manual instructions in here. We can choose change directory, which is CD, and we can type in some extra path here to get to the folder that we need. But this is long-winded and rather tedious. There is a quicker and easier way to get to the folder that we need. So I'm just going to close the command prompt window here and bring up a Windows Explorer window. Let's just bring this into the screen. And you can see straight away that we are in the UDK binaries Win64 folder that we were in when we saw the command prompt window earlier. And I want to open up the command prompt in this folder here. And there's a really quick and easy way to do that. All I have to do is hold down the Control key on the keyboard along with the Shift key and right click on the background. And when I do this, we get a context menu appear, and on this menu you can see the option here which says opened command window here, and I can click on that option and straight away a command prompt appears, and it is in the folder that we need. So that's really just a quick way on how we can open up the command prompt anywhere on any folder that we want. So let's just jump back to our command prompt window and see how we can run the UDK compiler. Now, to compile our code, all I have to do is type UDK make and press enter on the keyboard, and that goes ahead and recompiles all of our code, 0 errors, 0 warnings, and it took 0.73 seconds. So pretty quick. It really is that simple. The only problem with this method is that every time we make changes to our code, we've got to come back and type in these commands. Now, there is a way we can automate this process using Notepad++, and I'm going to show you how to do that now. So here we are in Notepad++, and I have two source files open here, GameInfo and Actor, and these are part of the UnrealScript source code. Now, these are very important files, but we'll be taking a look at them in more detail later in this course. Here I want to show you how you can recompile your source code from Notepad++. Now, if you have a look at the menu options at the top, you will see that there is no option to do that. However, if you have a look at the Run menu, we have a number of options for running other programs here. What we can do is add the UDK compiler to this list. Now, to do that, I'm going to select Run from the menu or press F5 on the keyboard. And when I do that, this Run window appears here. All I have to do is enter my program in this list here. So I'm going to click the ellipsis button. And with the open dialog in front of me, I'm going to navigate to the UDK folder, choose Binaries, Win64, and select the UDK executable here. And after this, I'm going to be adding the command make, as we've seen before, and choosing Save. Now this gives me the option to add the command to the menu, so I'm going to call the command UDK build. I'm going to give it the keyboard shortcut of F9 and choose OK. I'm just going to close this dialog by clicking cancel, and now from Run and UDK build we can also press F9. This option is permanently available to us now. We can compile our code just by pressing F9 or selecting this option. So I'm going to select UDK build and then bring this into the window, and you can see that it has recompiled our code. It really is that easy. I'm going to be using this from now on. So what I want to do here is show you an alternative method for building and compiling your UnrealScript applications using the Unreal front end, which is an application that comes with the UDK. You can find it in the binaries directory. Now on my desktop I have a shortcut to that application, and I'm going to double click it to launch it here. User account control comes up to give me permission to use the program. I'm just going to say yes to that, and here we have the Unreal front end appear. So here is the user interface, and the way this works is we press the start button and it goes ahead and compiles the application. Now we have the start button which will launch the compilation process, but then it performs these other steps that we have here all in order from left to right. So when I press start, it will move to step 1, which involves compiling all the scripts that we have written. So if I press on this drop down arrow, we can choose to disable that step if we want to, but I'm going to leave that enabled, and generally I recommend that you leave that enabled. We have the cook button, which is the next step, and that compiles all of the light mapping for the levels, including all the collision data and all the other level metadata. Again, I recommend that you leave this enabled. We then have the next step, which is launch, which allows us to run the game to test it after the cook step. I'm going to click on that and make sure it is not enabled. I don't want to test the game. And then finally, we have the package game button, which will compile all of the game data and put it into an installer package that we can give to end users so they can install and play our games. Now on the left side here we have profiles, which really just contain a set of compiler settings. I'm going to leave it at DM deck because these are the settings that apply to really compiling a game for a PC. Here in this maps to cook list here, this is very important. It contains a list of all the levels that should be in our game. Right now it says DM deck. That is a level that comes with the UDK, but typically when making our own games, we will add our own levels. Now I'm going to click the add button and you'll see that we have a list of all the levels that we can add. If I just bring up a Windows Explorer window, you can see here that we're in the Content Maps folder, and the list that you see in the Unreal front end is a list of all the maps we will find here. So I'm just going to minimize this window. I don't want to add any other maps, but really when creating this list here, what you should ensure is that this list contains all the files, all the levels for your game, no more and no less than that. If it contains more levels than are in your game, if it contains levels that are not in your game at all, then you will end up building a package that is larger than it should be. If you have a level that is not in this list and it should be in this list, then your game will probably crash when it comes to access that level. So make sure this list features all the levels in your game. To launch the compilation process, all you have to do is just press the Start button and it will be compiled to this target directory here. So I'm going to go ahead and press the Start button. We can click on the drop down and access a range of options. I'm going to choose Start, Full Rebuild and Recook, which will recompile and rebuild everything. So I'm going to choose that option, and you can see here in the compilation window we get a whole series of results here. This may go on for quite some time and shows quite a lot of data. So I'm going to resume recording when this is left off. So now our game is finished compiling and we get this game setting window appears that allows us to name our game. So I'm just going to call this Super Game and leave the game name Super Game here and choose Package Game. And I'm going to press that button and straight away it will start to compile all of the necessary files to include in our game package. And when this has completed, when we return to the UDK directory, we will see that our game has been packaged. So let's bring up this UDK window and return to the main UDK folder. And you can see here in this folder we have UDK install Super Game, and it has compiled our executable into a single installer. We can go ahead and distribute this to our end users who will be able to install and play our game. So that is an alternative method for compiling UnrealScript applications. So before we get started creating our game, I'm going to give you a sneak peek into the future and show you the final game, the game in its completed form. This is the game we're going to be making. So what we have here is a DM deck based level which is filled with different statue objects, and these are going to be our power-up objects, and the objective of the game is to collect all 10 of them. So we begin at the level beginning here, and you can see each statue is rotating. And we walk through the statue and you can see on the left hand side that it's printed how many statues we have collected, and each time we collect a statue it stops spinning. And finally, when we reach the end of the level and we've collected all 10 statues, a platform raises out of the ooze. We can stand on the platform and complete the level. It's a pretty simple game, but in creating it we're going to see a lot of different UnrealScript concepts. Okay, so let's get started at creating our game in UnrealScript. Now, in this course, I'm going to be using an existing level that comes with the UDK. We're going to be having our game take place inside this environment here. Now, to access this level, you simply need to click File and Open and navigate to, from the content directory, you can navigate to the Maps folder and the UT3 folder, and here you will see the level DM Deck. So I'm going to open up that level by double clicking on it, and this is the level that we have here. And I'm going to save a copy of this level by choosing File and Save As. And I'm going to name this copy here My Level so that we do not overwrite any of the original data. And I'm going to choose Save so that we save a copy which is My Level. This will be our version of the level here. So inside this level we're going to have our game take place, and what's going to happen with our game is we're going to be able to collect a number of different power-ups in the level that we will script, and when we have collected all of the power-ups, it will activate an event in the level, and that event will end the level for us and complete the game. So we're going to get started at coding that, and we're going to see how to do that next. Whenever you're ready to create a new game in the UDK with UnrealScript, one of the best practices, one of the first things that you want to do is to create a new folder inside the UDK directory that will hold all of the classes that you are going to create. So to do this, we need to visit the development folder and the source folder. We've seen this folder before. This contains all of the UnrealScript classes that come with the UDK. All of these folders that we see in front of us, I have not created. They were automatically generated when the UDK was installed. What we want to do here when we create our new game is to create a new folder inside this directory. So to do that, I'm going to right click on the background and choose New and select Folder, and I'm going to call this folder My Game because it's going to house all of the files for my game. Typically you will give this folder the name of your game, but for this I'll just call it My Game. And I'm going to double click to open that folder, and inside I'm going to create another folder which is going to be called Classes. And this folder will house all of the UnrealScript source file that we will create for our game. Whenever we want to add new behavior to our game, we're going to need to create a new class, and that will involve creating a new source file inside this folder. So we're now ready to get started at coding our game, and the first question remains as to which class do we need to create first? Where do we begin? And we're going to have a look at how to do that next. So here I am in UncodeX, and I'm just having a look at the UnrealScript class hierarchy to ascertain where we should begin. Now typically whenever you create a new game, one of the first classes that you want to create is a manager class, a class that manages the events of the game, defines the logic and the rules. Now in UnrealScript, the classes that do this extend from the GameInfo class. You can see here that we have the GameInfo class in the development source engine classes folder in gameinfo.uc, and you can see the contents of that file here. This is a script file that comes with the UDK, and we typically derive from this class in order to create managerial classes. Now, not all manager classes have to descend directly from GameInfo. They can extend from other classes, which in turn extend from GameInfo. For example, we have the UTGame class. Now the UTGame class contains a whole load of code which is designed to get us up and running really quickly at creating a first-person shooter game. So I am going to be descending from the UTGame class so that we can have first-person shooter functionality already in our game, and we can just start refining from there. So the way to get started, I'm just going to minimize UncodeX, and I'm going to bring in a Windows Explorer window. And you can see we're here in the development source My Game Classes folder, and I'm going to go about now creating our first script file. So let's create our first script file. I'm here in a Windows Explorer window in the development source My Game Classes folder, and I'm going to create a new file by right clicking and choosing New from the menu and choosing Text Document. I'm going to create an empty text document here, and the name of this file is very important, because in UnrealScript the name of the file should match the name of the class we create inside the file. So notice that the GameInfo class, that's inside the gameinfo.uc file. So the file names must match class names. So I'm going to be calling this class collection game and info, and I'm going to give this the extension of .uc because it's an UnrealScript class file, and press enter on the keyboard. It asks me if I want to change the name. Yes, I do. I'm absolutely fine with that, so I'm going to choose yes. And here we have an empty file, collection game info.uc, and if I double click this file, it opens automatically in Notepad++. The file right now is completely empty, completely blank, but that's absolutely fine. We've now got a good beginning to start creating our collection game info class. Okay, so here we have a completely blank collection game info UnrealScript class, and we want to get started. Now, to begin, I'm going to create perhaps the simplest kind of class possible. It's going to be a game info class that will print the message "Hello World" to the screen while the game is running. So it's a Hello World class. We'll start simply with that and then extend from there. Now, of course, coding Hello World behavior is not directly relevant to our game per se. It's just an exercise. But what it's going to do is it's going to show us the basics of how UnrealScript works. So it's a fruitful exercise. So the first thing I want to do is create a comment for this class, which I'm going to say is collection game class. And notice that comments in UnrealScript work much like C# or C++. You prefix the line with the 2 forward slashes. I'm going to declare the class collection game info, and when I name this class, I'm going to be very careful here that the name of the class matches the name of the source file here, and this class is going to extend from the UT game class, which, as I've mentioned, descends ultimately from the game info class. So by extending from this class, we ultimately extend from the game info class. I'm going to create a default properties block, and this is basically the constructor function of the class. This will be initialized on the class creation, and we're going to be using that later, so I'm going to come back to that. We can leave that blank for now and put a semicolon at the end there. So for our purposes, it basically means that when our program begins, the code inside this block will be run or will be executed. So how do we print Hello World to the screen? Well, there are all kinds of ways of doing this, but one way is to override a function and put it in there. So I'm going to create an event called tick, which is going to be called once every frame during the game. So every frame in game, this function is going to be called. This tick function is going to be called every frame. Now, just to refresh your memory, an event is a special kind of function that will be run automatically when particular events happen in the game. So now the classes that we are descending from, the UT game class and the game info class, they perform a whole load of code and other things on the tick event. So we don't want to override and completely replace their functionality. We just simply want to extend from it. So to make sure that the ancestor classes get this tick notification, we have to type super tick and delta time, passing it that argument there. This will call the tick function on all the super classes, the ancestor classes, which will be UT game and game info. And then after this call, we can go ahead and do what it was we wanted to do. We want to print Hello World to the screen. And a really quick way of doing that is by calling the broadcast function. We just type broadcast self and hello world with an exclamation mark. So the broadcast function will print the message hello world to the console. Now I'm going to save all of these changes and press Ctrl S on the keyboard there to just save all of those changes. And actually I've made a mistake. You see I've got an opening quotation mark there. I've got to make sure I'm closing one, so that's absolutely fine, but the compiler would have picked that up anyway. So I'm going to press Ctrl S, and then we're going to get ready at compiling our class. So here I am in the UDK editor, and I'm now ready to go ahead and compile our collection game info class. Now before you go ahead and compile any classes, I want to say something that is very important. Make sure before compiling that your UDK editor is completely closed. Shut down the application, So click File and Exit. Completely close the Unreal Editor because it will affect the compilation process. So I'm going to bring up Notepad++, and here we have our collection game info class, and this really is as simple as any class gets. So let's go ahead and compile. I can do that by clicking Run and using the UDK build option that we created. So I'm going to select UDK build, and this will open up the compilation window. I'm going to bring this in here, and you will notice that we have a problem. It says no scripts need recompiling. We have success, 0 errors, 0 warnings, but it says no scripts need recompiling. Now we know this is not true because we have just created this coin collection game class. We know that it needs compiling. So it seems that the UDK is not recognizing this source file for some reason. It doesn't seem to know that it is present. How can we go about fixing that? Well, the way we need to do this, let me just minimize Notepad++. Let's bring in a Windows Explorer window. We need to tweak some settings in an INI file. In particular, open up the folder UDK game and the folder config. And if you scroll through this folder, you will see that there is a file which says udkengine.ini. We need to open up this file in Notepad++ and tweak a few settings. So I've opened up the udkengine.ini file in Notepad++, and I've scrolled down to this section here which says unrealed.editor engine. This section is where we are going to be specifying the script files that we need to include in the compilation process. And if we scroll down to the bottom, we need to add a line which says mod edit packages, and we need to specify the folder name where our classes are stored. In this case, it's my game. I'm going to press Ctrl S on the keyboard to save that. And now any classes we put in there will be included in the compilation. So now when I return to my class, I choose Run, UDK build. Let's bring back the compilation process, and now notice it compiles, and notice that at the bottom it includes my game in the compilation process, and thankfully we have 0 errors, 0 warnings. Our class is now compiled. Our code is now compiled, and to prove it, let's visit the UDK game directory here and have a look in the script folder. And you will notice all these files end in .u. We mentioned that these are the compiled versions of our code, and you will notice we have a file here, mygame.u. This is the compiled version of our class, and this is the version of the code that the UDK will actually use when games are running. So now let's test out our class actually running in a game. To do that, I'm going to return now to the UDK editor. So I'm back now in the UDK editor, and we can see that we have our level open here. Now we can choose any level. We don't have to use the DM deck level, at least not yet. We can work with absolutely any level we like because the game info class just defines the rules of the game, and that can work with more or less any level that we choose. So I'm going to, just for test purposes, work with this level we have in front of us here, which is the default level that opens with the UDK editor. Now to specify our game info class, we need to move up here to the menu and choose View and choose World Properties. Select World Properties from the menu, and we get this World Info Properties dialog appear. Now we need to, in here, specify the game info class that we're going to be using to govern the rules of the game. I'm going to unwind this game tabs section here, and you will see that we have game type for PIE. PIE stands for Play in Editor, and we're going to specify the game info class used for the game when we press the play button in the editor. So in the drop down list, I'm going to select our game here. You can see it in the list. There are many different types of games, but I'm going to select our one, which is Collection Game Info, and select that from the list. And now that is active as the Play in Editor Game Info class. All I need to do now is just close this World Properties dialog, return back to the editor, and press play on the toolbar here. And now our game is playing, and you can see here on the left hand side is a whole stream of hello world messages because they are being printed to the console on every frame. So we're having hello world, hello world, hello world, every single frame queuing up in the console here. So now we can see our game info class at work, and this is a good start. Now I just want to show you one issue that can arise when working with your config files. Let me just bring up the config file directory that we have here. You can see this here in Windows Explorer, and we have all of the INI files that we have used. We use the UDK engine.ini file, and if I just double click that file to open it in Notepad++, I press Ctrl F on the keyboard to bring up the Find window, and I want to search for mod edit packages. And here you can see on line 560 that I've added the mod edit packages line with my game, and we've specified it here to include the source files in the my game directory. Now we've seen how to do all of that, and that will work absolutely fine. And for our project, I'm just going to leave it here in this config file. But one thing it is important to mention is that sometimes these UDK files, all of these files prefixed with UDK, they can be deleted or overwritten, and sometimes they are regenerated. And when they are regenerated on the basis of these other files here, which are prefixed with the word default. So the default engine here will be used as a basis for reconstructing the UDK engine.ini file. So what does this mean? Well, it means that sometimes the default settings here can overwrite the settings inside the UDK engine file. So this means that often when we want to insert our mod edit packages line, we will do that in the default engine.ini file instead of the UDK engine.ini. So I can just double click on the default engine, and we can add our mod edits to this file instead of the UDK engine file. So you may want to do that on your larger projects, but in this case here for our project, we're not going to be doing anything that will cause these files to be overwritten, so we can leave these settings as they are. So we've gone ahead and we've created our own game info class, and I just want to put that on hold for the moment. I just created the game info class right at the very beginning of this course to show you how quickly we can get up and running in UnrealScript just by using the game info class. We will come back to that. But right now I want to consider something of a more important need for our game. You can see that I've got open in front of me the DM deck level that we have saved. We're going to be using this environment for our game. And what I want to do is I just want to remember that we're going to be creating a game where the player runs around this environment and they collect power-up objects or artifact objects. I want to show you the mesh that I'm going to be using for these objects. You don't have to use the same mesh as me. You can use any mesh that you like, but I'm going to show you the one I will be using for this course. It comes with the UDK. I'm going to press Ctrl Shift F on the keyboard to display the content browser, and in the search field I'm going to search for castle_assets.meshes and .sm monk statue, and you can see the monk statue here in the content browser. I could, if I wanted, drag and drop that into the level, and you get a feel for the statue that we have here. Let's just close the content browser, and here we have the statue in the level. Now, the player is going to be running around collecting these statue objects, which is absolutely fine. Let's just rotate him around so that we can see him a bit better. But we cannot just drag and drop these meshes into the scene, because we want to attach some custom behavior to these power-ups. For example, I want these power-ups to be constantly just spinning around like so, and when the player runs through them, they will collect them, add them to their inventory, and will also play a sound when the player collects them. So we have some specialized behavior that we want to apply to these objects. Now, to achieve this in the UDK, we need to create our own specialized actor class. Everything we can put into the level is a form of actor. So we need to go ahead and create our own actor class. So I'm going to jump back to Notepad++ and create our actor class. So here I am in Notepad++, and if you look at the title bar, you will see that off screen I've gone ahead and created statuepowerup.uc, an empty script file in the folder My Game Classes. This is the same folder where we will find the collection game info class, so both of our classes are stored in the same folder for our game, and we're going to be creating this actor class to apply to all the statue power-up objects. To get started, all I need to do is type class, and remember the name of the class must match the file name, so statue power up, and this class is going to extend from the actor class, and press Ctrl S on the keyboard to save those changes. And there we are, we have the beginning of our actor class. Right now it does nothing, but we've got more to add. Now I don't know about you, but whenever I make games, I like to make my life as simple as possible. And what would be really great for our game is that once we've completed coding the actor class, it would be great if we could just save it, compile it, and then open up our level, open up the content browser, switch to the Actors tab, and you'll see that in the Actors tab we have lots of different categories and names of different items, and these are just actor classes that we can just click and drag and drop right into the level and add these actors to our level. It would be great if we could have our actor class in this list, so we could just drag and drop it into the level whenever we wanted a copy. Well, it just so happens that we can do that using a special command in UnrealScript. And I'm going to jump over to Notepad++ and show you what that command is and how it works. So I'm back here in Notepad++ with our actor class, and really to have our class added to the actors menu, all we need to do is insert a new line after the extends from actor statement and insert the command placeable. That indicates to UnrealScript that we want our class to be placeable in the level, that the designer can drag and drop it. And I also want to add the statement class group, and we have to give the group a name. This is the name of the group that's going to appear in the list. So I want to call this one just my game and give the actor a name, as the name as it will appear in the list. So I'm going to call this statue power up, like so, and choose Ctrl S, and there we are. We can now compile that UDK build. Bring over the compilation window, we can see this compiling away, and there we have 0 errors, 0 warnings. Our code is now compiled. We can return to the UDK editor and see our actor in the list. So back in the UDK, let's see if our code worked. I'm going to press Ctrl-Shift-F on the keyboard to display the content browser. I'm going to switch to the Actor Classes tab, and we will see the categories. Now we can see here, these are listed alphabetically. So I can see here my game, which is the name I gave to the group. We gave the statue power-up subgroup, and we have our class statue power-up. We could come in and tweak these names so that there wasn't a duplication there, but I'm going to leave these as they are. They are fine in this case. So we have our statue power-up object, and we can just drag and drop that into the level, and you can see that now the actor class is in the level and it's represented by this gizmo object here. Let's just close this actor classes window and return and have a look at our actor class. So we can see that everything looks fine for this object. I mean, it's in the level, but there's no physical representation of our actor. We don't have that monk mesh to represent it. It's just a completely empty object, and if we select something else, it suddenly becomes very difficult to select our actor again. So we're going to be dealing with that next. Okay, so here what I want to do is to configure our UnrealScript power-up class so that when we drag and drop it into the level, we get a mesh representation as opposed to just a blank gizmo. Now, to do this, we're going to be adding quite a bit of code. I'm not going to type in every single statement. Instead, I'm going to paste in the code and then explain what it does to save time. So the first thing we're going to do is to insert some variables into this object. I'm going to paste them in here, and we can see that we've got two lines. We have a statue mesh component and a light environment component. Components are things that we can add to the actor object. The actor begins completely empty, and we can begin to add components to it to define how it works. So I'm giving it a mesh component because we want to have a mesh attached to this actor. And I'm also giving it a light environment component so that it can be illuminated properly by real-time lighting. Now you may be wondering what the difference is between the keywords const and edit const. The keyword const means that UnrealScript will treat this variable as read-only, so that we cannot change its value elsewhere in UnrealScript. The only exception to that is the default properties block. In there we can set the value of the variable. And the keyword edit const just ensures that the variable is treated as read-only from the UDK editor, so that if we can see the variable inside the property window, we cannot even change its value there. Now these are just variables that we have declared. We still have to initialize them, and we can do that using the default properties block. So I have more code to paste in there. Okay, so let's open up the default properties block here. Let's just open these braces, and I'm going to paste in some code, so Control V, and here we have the code that sets up our mesh and light environment components. This first group of lines here defines the myLightEnvironment. We create a dynamic light environment component. We give it the name myLightEnvironment, and notice that here in this statement we assign this light environment object to our variable light environment, which you can see here. And we then use components.add myLightEnvironment to add it as a component of this actor. And here we're doing something very similar with the mesh object. We are creating a new static mesh. We're calling it body mesh, and we are specifying this mesh to be a static mesh, and the name we are specifying, the name of the mesh asset, is castleassets.meshes.smmuckstatue01. This name matches the same name that appears for the mesh in the content browser in the UDK editor, so you could specify the name of a different mesh here to add your own mesh if you don't want to use the monk statue mesh. Here I'm assigning the mesh to the variable that we have created, statue mesh, and finally components.add, and we're adding that mesh as a component of the actor. I'm also enabling the enable colliders to turn on collision detection, and I'm also disabling block actors so that our player character can walk through the object to collect it. Now we haven't completed all the behavior for our actor yet, but I'm going to press Ctrl S and then compile this code and then quickly test it in the UDK editor. So I've compiled our code, jumped over to the UDK editor, and I've unwound our MyGame statue power-up and statue power-up object. All we have to do is drag and drop this into the level, and ta-da, you can see straight away that we've got a statue as we drag and drop it. Going to drag and drop another one, and drag and drop another one, and another one, and this is looking good. Of course, these statues don't do anything just yet. We haven't customized the behavior, but they are there, and we can now finally select our actor and see it, and it has a presence. So good, let's move on. Okay, so now I want to refine our actor class even further by adding some additional variables. Now we know several things about our actor. For example, we know that it's going to be continually rotating. So we could add, for example, a var float rotation speed, where we could specify the speed of rotation. We can add another variable, for example, which is var sound q, and we'll put q sample. This would be a reference to the sound file, the asset from the content browser, the sound asset, that we want to play whenever the player collects the power-up object. We may also want to give each actor a unique name. So I'm going to type var string, and I'm going to call this actor name, like so. So the player, or the designer, beg your pardon, can give the actor a unique name that they choose. Now we could just press Ctrl S and compile this code and leave it here. But the thing is that what would be really great is we want to be able to view and edit these variables from the UDK editor. For example, if we want to change the rotation speed, or change the sound that plays when the player collects the power-up, or if we want to change the name of an actor, we don't want to have to jump back into the UnrealScript code and recompile and change everything. Instead, it would be great if we could set these values from inside the UDK editor. So there is actually a feature that allows us to do this. And to do it, all we need to do is just make sure that the var keyword is followed by an open and closing bracket. And there, that is all we need to do. By using that syntax, we can expose or publish these variables in the UDK editor. So I'm going to press Ctrl S on the keyboard, choose Run and UDK Build, recompile our code, let this whiz away and do everything that it needs to do, 0 errors, 0 warnings. Now let's jump back to the UDK editor and see how we can set and change these variables. So I'm back here in the UDK editor and I'm going to insert an instance of our actor into the level. So statue power up, drag and drop that into the level. And now with any actor selected, it doesn't just have to be this actor, it can be any actor. I'm going to select our one and press F4 on the keyboard. And when you do that, you can see we've got statue power up group here. But we get a whole range of properties that we can view and edit for the object. These bottommost groups are default properties that come with every actor. But we have this statue power up object here, this group, which are properties specific to our actor. And we have rotation speed, cue sample, and actor name. So I can just type object 01 for this actor here. I can come along and drag and drop a second power up statue here. Let's just close this dialog. Give this the name object 02. And now if I click between them, you will see that the properties change between these objects. So that's how we can go about using variables for our objects. So what I want to do here is just to spend a couple of minutes just recapping over where we have come and where we are going. So what we have done is we have created a statue power up class, and it extends from actor. And it is placeable. That means that we can insert it into the level from the UDK editor. We've created some variables and added some components, and we can see in the default properties block that we're adding those components there. Now if I minimize the Notepad++ and display the UDK editor, we can see our actors in the viewport here. Now if I select any one of these actors, so this one here is selected, and I press F4 on the keyboard, we can change the properties for the actor, and in particular we have the rotation speed and the cue sample. The rotation speed will be used to control how quickly this object will rotate or spin when the level plays. So right now I'm just rotating this manually, and even if I press play right now, this object will not rotate because I haven't coded that behavior yet. I still haven't coded it to rotate. We've got a variable set up ready to do it, but setting this to any value will not have any effect yet. We also have the cue sample, which allows us to choose which sound to play when the player collects the statue. But right now, no sound will play, even if I give this a value, because I haven't coded the necessary behavior to play the sound. These are things that we're going to be tackling now, and we're going to be coming up to. So let's get started with that. Now before moving on, there is something that I want to show you that is a pretty neat little tip. And I'm just going to bring up Notepad++ to do that. It is related to static meshes. What you can see here in Notepad++ is this test actor class. Don't worry too much about this class at all. It's not going to be part of the project. After this video, I'm going to clean out this file and delete it completely. I've just got this open here to show you, to demonstrate to you what it is I want to show. So here we have the static mesh section. You can see we've got a begin object, which begins a component that defines a static mesh object that is going to be part of this actor. And in the static mesh property, we're specifying here the mesh that we want to attach to this actor that's going to represent its body. You can see here that we're referring to the full name of a mesh, which is SM Monk Statue. And I want to show you a really quick way in which we can copy the full name of a mesh from the UDK editor, and then we can paste it into Notepad++. So I'm just going to minimize Notepad++, return back here to the UDK editor, press Ctrl-Shift-F on the keyboard to show the content browser, and I'm going to filter the selection here to static meshes only. So here we have a whole variety of meshes that we could add to this to our object. So for example, let's say that I want to use this mesh here. Now I can select that mesh, and if I right click on the mesh with my mouse, a context menu appears, and we have this option here which says copy full name to clipboard. So I'm just going to click on that, And now when I jump back to Notepad++, I'm just going to highlight everything here on the right-hand side of this equal statement. And I'm just going to right-click and choose Paste. And straight away it pastes over everything that we need. It includes static mesh and then the full name of the mesh as well. So that's a really quick way in which you can specify any mesh you like just by copying and pasting the name of a mesh from the UDK editor. So in Notepad++, we're looking over the UnrealScript code for our class, and the first thing that we want to address is object rotation. We know that our actor statue power-up will continually rotate around its own local y-axis. So if you imagine a pole stretching right through the center of the object, the monk statue is going to be continually rotating around that center. Now, to achieve this behavior, we're going to be using UnrealScript, and we're going to be using the tick function because the rotation behavior is something that happens on each and every frame. The rotation is good in practice generally because it helps emphasize to the gamer that the object is not grounded in the level, but is something that they can collect. So to insert the tick function, this is something that we have seen for the collection game info class. It's called on every frame. I'm going to be inserting this into the code, pasting it in, and then describing to you what it does. So I'm going to insert some space between the default properties and the variable declarations, then press Ctrl V to paste in the code. Now, of course, I do want to take this opportunity to mention a small tip. I'm copying and pasting code into the source file here merely so that you don't have to sit there watching me typing in every letter. But generally, it's not a great practice to be copying and pasting code. Ideally, you will be writing your own functions rather than pasting code here and there, because when you do that, you can easily make mistakes, pasting the wrong things, get things jumbled up, and just end up in a right royal mess. So be aware when you copy and paste. I'm just doing it here for speed and convenience. You can see here that we have tick function, and it accepts the parameter delta time, which is the amount of time in seconds since the last frame. Typically, this value is almost always a fractional value. It is between 0 and 1. So 0.5, 0.1, 0.2. These are usually examples of delta time. In any case, I'm going to explain what the tick function does now. So let's focus on the tick event. What this function ultimately does on each frame is it converts a delta rotation value, measured in this floating point number, into a rotator object, new rotation, which is specified in the last statement. We call a function setRotation, and we pass it the final rotation that we want to apply to our game object. Now, you will notice up here that we have the rotation speed, which is the amount of rotation in degrees that we want to apply to the object per second. So if this were 90, we would be applying a turn of 90 degrees per second. So let's take a look here. In the first statement, delta rotation, it equals the rotation speed multiplied by the delta time value, which may be 0 point something, a fraction of a second, and then finally it multiplies that by this special constant here, degree to unreal rotation, which converts degrees into unreal rotation units, so its own form of units for rotation. And then this value is finally output to delta rotation, which is the amount of rotation we want to apply to the object. Finally, we have new rotation, this rotator object here, which is where we get the current rotation of the object, and then we update its rotation in yaw around the y-axis by the delta rotation measurement, and then finally we set the rotation of the object. So I'm going to press Ctrl S on the keyboard, recompile this code, and then we're going to take a look at this in action in the UDK editor. So I'm here in the UDK editor, and it's time to put our rotation code to the test. Let's visit the Actor Classes tab and drag and drop the statue power up into the level and we can see that we have our object here. Let's just close the Actors tab. I'm going to press play on the toolbar to see our actor in the level. So our game begins, and you will notice that despite our code, the statue is not rotating at all, and that is because we haven't specified a rotation speed for the object in its properties. So I'm going to press Escape to exit play mode, and F4 on the keyboard to display the statue power-up properties. You can see for the rotation speed value, the value is 0, meaning 0 degrees per second. We don't want to rotate at all. I'm going to set this to 90 to specify a speed of 90 degrees per second. I'm going to close this and press play on the toolbar, and you will see that when I do that, hopefully, yes, there we are, the statue is now rotating 90 degrees per second. I still think that is a little bit slow, so we can increase the speed quite easily. I just press Escape to exit play mode, F4 again, and we can begin to tweak these properties. So I'm going to put in a value of 180 degrees and then choose play on the toolbar. And as soon as the level begins, you can see that now it's turning a bit faster, and this is looking much more power-up-like. So we're going to be populating our level with many of these different statue objects that's going to be rotating to indicate that we can walk through them and collect them. So that really is how we can get up and running with object rotation in UnrealScript. So what I want to do now is to set up our class so that we can detect when the player collides with it. We want to be able to know when the player has collected one of our power-up objects. And we can do that by using the touch event. Now, before I go ahead and get started with that, let's scroll down to the bottom of the class. These two properties at the bottom of the default properties block are very important. We have B collide actors equals true, which enables collisions. It allows us to receive collision notifications. And B block actors equals false will allow our player object to walk through the power-up as opposed to being blocked by it as though it were a solid object. So what I'm going to do now is scroll up in the source file, and above the tick function but below the variable declaration, I'm going to paste in a touch event. And this is the touch event that we have here. Now, the touch event accepts a range of different parameters here: actor, primitive component, hit location, and hit normal. I'm not going into the details of these right now. They are not too important for our purposes. What we perform here is an if statement, and what we are doing is we are checking to see if the object that we are colliding with is the player and whether it's a human controlled character. So that's what we're checking for here. Is this a player controller? So is the player the object that we are colliding with? If it is, then we call the function play sound, and we pass it this value here, which is Q sample. This is the variable we specified up here, which is a reference to a sound cue, a sound effect file that we can specify from the content browser. So when we touch the statue, we're going to play this sound effect. So I'm going to press Ctrl S on the keyboard to save these code changes. Move up here to the Run menu, choose UDK Build. The compiler will process all of this source code, compile it. We get 0 errors, 0 warnings. Our code is now compiled. Let's give this a test in the UDK editor. So I'm back here in the UDK editor, and I have the content browser open, and I have chosen the sound cues filter, and I have found this sound that I'm going to be using when we collect the statue object. I'm just going to double click it so you can hear it. And there we have the sound effect. I'm just going to move the content browser out of the way, and you can see we've added a statue to the level, and I'm going to press F4 on the keyboard and press the green arrow in the Q sample slot to load that sound into there. And then I'm going to press play on the toolbar and just simply walk through our statue, and we'll hear the sound being played. So once, like so, I can walk back and hear it being played again and again. And so there we have our sound cue up and running. Okay, so let's assume now we've got our power-up object, but when the player collects the object and walks through it, we want it, let's say, to stop spinning. we have it spinning beforehand, but when the player collects it, we want it to stop. Now, when you think about the power-up in this way, you can see that it exists in two different states. It is in a spinning state before the player collects it, and once we've collected it, it stops spinning. Now, we could code this functionality by creating a new Boolean variable here in the variable section. And in the touch event, we could set that Boolean to true. Then in the tick event, we could check to see if the variable was true. If it was not, then we would continue spinning the object on each frame. Otherwise, we would ignore the spinning behavior. We could go ahead and do that by coding the functionality that way, but UnrealScript provides us with a neat feature called states, which allows us to mimic this kind of behavior and doesn't require us to use any conditional statements to do it. So let's take a look at how we can use states to achieve this. So we have the spinning state, which is the default state of the object. And I'm going to code that into the class by creating state, and I'm going to name it spinning, and I'm going to put an opening bracket here, and I'm going to scroll down and put a closing bracket after the event tick function. I'm going to select both the tick function and the touch function and indent them so they are very clearly now inside the spinning block. So we have state spinning, and the event touch and tick are both part of spinning. Now, whenever this class enters a state that is not spinning, the touch and tick events, as we have defined them here, will no longer appear to belong to the class. So the question is, we have this state spinning, but how do we know that the class begins in this state? To do this, we can use the auto state feature. So I'm going to come into here and type auto state and type default state. When the class is created and begins, it will begin in this auto state, this default state here. And when this state begins, I want the class to switch to the spinning state so that our power objects begin in the spinning state. Now, I should mention that states are mutually exclusive. So if you have a bunch of functions inside a state and your class is not in that state, then those functions are undefined. They will not be executed. So a class can be in just one state at one time, and all the functions grouped inside that state can be executed when the class is in that state. So I'm going to type the statement begin, because that's when the state begins, and I'm going to call the function goToState and specify the name spinning, which is the name of the state that we want to go to, in this case, this state here. So when the class is created, we enter the spinning state, and that is a good beginning, but we've not finished yet. So we have our class in place with a standard spinning state. But of course, once we collect the power-up, we want it to enter a deactivated state. Well, we can add that quite easily by just scrolling down to the bottom of the spinning state that we have defined here, so just above the default properties block, and we can insert a new state, deactivated. Like so. I'm going to put a closing and opening brace here, and it's going to be completely empty because on the deactivated state, we don't want to have a tick function called on every event to rotate the object. And we don't want a touch event to work out if the player has collided with the power-up. At that point, the object is deactivated. The only question is, how can we change between the spinning state to the deactivated state? Well, that's quite easy. All we have to do is go back to the touch function when the player collides with the object, and just before or after we play the sound cue, we want to deactivate the spinning state and switch to our deactivated state. And we can do that just by using the goTo statement that we've used up here already. So I can type goToState and I can choose deactivated. So it will switch to the deactivated state and leave the spinning state. And there we have coded the basics of our power-up class. Let's jump over to the UDK editor and see these states in action. So I'm here in the UDK editor, ready to test out the state functionality of our power-up class. So in the actor classes panel here in statute power-up, I'm going to drag and drop an instance of our power-up onto the level platform here and just position that. And I might in fact put in a second one here. So just pull that into the level. raise it above the platform just a little bit. Now, an alternative that you can use for positioning the objects is you can just hover it in the air and then press the End key on the keyboard, and the object will automatically snap to the nearest ground plane. And then just close the active classes. And for each of these, I'm going to activate their spinning behavior and specify a rotation speed so that we can see the difference as it stops rotating. So I'm going to select the first statue, press F4 on the keyboard, and I'm going to set the rotation speed to 360 here, like so. And I'm going to select the second power-up and set the rotation speed to 360 as well. So just accept both of those and then press play on the toolbar. And then I'm just going to run through both of these power-ups. So through one, through the second one, turn around, and oh look, both of them have stopped rotating completely, and that is because both of them have left the spinning state and have entered the deactivated state. And in the deactivated state, neither of them receive the tick event. So the tick event is not called on each and every frame. It's not called at all because the deactivated state doesn't have a tick event. So they have all stopped spinning. And that's how you can get up and running pretty quickly with states. I recommend you use the state feature of UnrealScript for a lot of your work. It can save you a lot of time and a lot of effort. So now we've created our statue power-up class, and it's almost time to move on and re-examine the collection game info class that we started at the beginning of this project. You can see here that it's still configured as a Hello World application. Now, before we move on and begin to add detail to this class, I just want to switch back to our statue power-up file and show you something. Now, right now, when we collect a power-up, it switches to the deactivated mode using the goToState statement. And when in deactivated mode, the power-up simply stops spinning. That works absolutely fine, as we have seen, but some people may prefer the statue to completely disappear from the level. They may prefer it to be removed from the level rather than simply to stop spinning. If that is the behavior that you want, then you can remove this goToState statement and replace it instead with a destroy statement. You can call the function destroy, which is a member of the actor object, and it will delete the actor from the level and completely remove it. So if you want to remove your power-up from the level, you can call destroy instead of goToState, and that will handle your behavior that you need. I'm going to remove the destroy statement because I'm happy leaving it with the goToState functionality, but if you want to use the other method, now you know how to do both. So I'm going to switch back to the game info class, and we're going to get started at really customizing this class. First, I'm going to remove the tick event because I no longer want it to be a Hello World application. And we're going to be looking now at how to code the main logic for our game. So to code the main logic for our game, I'm going to be adding 3 unique variables. Now, together these variables are critical variables. We're going to have one variable, which is going to be var int statue counter. This is going to be the number of statues that the player has collected throughout the game. We're going to have a second variable, var int statue limit, which is going to be the number of statue power-ups that the player needs to collect in order to complete and win the game. And then the third variable is going to be var bool game1. This variable will begin as false to indicate that the game has not been completed, that the statue counter does not exceed statue limit. And then it's going to be true when the game has been won to say, hey, the player has completed the game. So I'm going to press Ctrl S to save these values. Now, of course, these properties here are not yet set. They are going to be set throughout the game. So we're going to be dealing with handling that functionality. So let's get started at creating the main logic for our game. And the first thing that I want to do there is to initialize our 3 variables here to starting values. Statue counter, statue limit, and game1. I need to set these to starting values, and I can use the default properties block to do that. So let's set the game1 variable to a starting value of false to indicate that when the player begins the game, the player has not yet completed the game. So that really just makes sense. The next thing I'm going to do is to initialize statue limit to 10, and that means the player must collect 10 statues in order to complete the game. The next thing I'm going to do is set the statue counter to 0, meaning that when we begin the game, we have not yet collected any statues. And the final variable I'm going to set is bDelayedStart equals false. This is an inherited variable. I'm going to set that to false to ensure that when we play back the game, there is no delay at the beginning. The game begins immediately. So I'm going to press Ctrl S on the keyboard to save all of these changes. And then next I'm going to code the main functionality of these variables. To do that, I'm going to create a new function, which I'm going to call statues collected. So function statue collected. This function is going to be called every time the player collects a statue. And what we are going to do is increment the statue counter, check it against the limit, and if we have exceeded or matched the limit in terms of the number of statues we have collected, we are then going to set the game1 variable to true to indicate that we have collected enough statues to win the game. So the first thing I'm going to do in the statue collected function is increment the statue counter by 1, so I can type statue counter plus equals 1, and that increments the statues counter. So if we collect one statue, statue counter is going to be set to 1. If we collect our second statue, it's going to be set to 2, and 3, and 4, and so on. The next thing I want to do is just print a message to confirm that we have collected a statue. So I'm going to use the broadcast function to print a message to the console to say, hey, you have collected a statue. So this is going to be statues collected, and I'm also going to show the number of statues that we have collected. And I can use this syntax to print the value of the statue counter. So we have here broadcast self, going to print the message statues collected, and then we can use this syntax here to print the value of the statue counter variable. And that is going to be incremented on this line here. Then next I want to check the value of the statue counter against the statue limit. So to do that I can type if statue counter is greater than or equal to statue limit. If we have collected the necessary number of statues, then the game1 variable is going to be set to true to indicate that we have completed the game. So I'm going to press Ctrl S on the keyboard and then compile this by choosing run UDK build, and here we have our window. It's compiling that code, and you'll see, ta-da, 0 errors, 0 warnings. Our code is now compiled. So let's move on. So I'm here in the statue power-up class, and before moving forwards I want to discuss two issues with you. First, I want to show you a quick tip that can be really useful, and second, I want to discuss the naming convention for variables in our project. So let's start with the tip. Right now I'm in the statue power-up class, and you can see that we've got all of the variables that we have seen before. I just want to draw your attention here to rotation speed. Now let's say, for example, that what we want to do in code at the beginning of the level, when the level begins, we want to search through all statue actors in the level and set their rotation speed. So we don't care how many statues there are, all we want to do is find them all and set their rotation speed automatically in code. Now, I'm not going to be actually doing this in our game, but I want to show you here how you can do it if you want to, because it's a really useful thing to be able to do when you are creating your own actors. So to do this, I'm going to jump back to the collection game info class, and we're going to be adding a post login event. This event is called when the player first enters the level. And so for a single player game, it has the effect of being called at the very beginning of the level. So I'm going to insert some space here and press Ctrl V to paste in my code that I've created off screen. So we have our post login event here. And the real magic happens in these lines here, this for each statement. You can see that we're calling for each and all actors. And what this has the effect of doing is it searches through the level for all actors of this type. So we're searching through the level to find statue power-up objects. And for each iteration of the loop, for each actor that we find, one by one, a reference to that actor is stored in this local myActor variable. And then inside the braces here, all we have to do is access myActor dot and any of the variables that we want to set. So that really is a quick way of how you can search through a level and set the properties of your actors. So next let's talk about the naming convention for variables. What I want to do is to show you Hungarian notation and how it can make your code a bit easier to read. It's a completely optional convention, but it's used quite a lot in the games industry. So let's take a look at the three variables in our class here. We have game1, statue limit and statue counter. Now right now these variables do not conform to Hungarian notation, but we can easily make them do so. For example, let's take a look at the game1 variable. We know that this is a type bool, that's the Boolean data type. So what we can do is just add a lowercase b to the front of game1, b for Boolean. So the statue limit variable here, this is an integer data type. So at the beginning of this variable name, we can add a lowercase I for integer, like that. And the same for statue counter. This is also an integer, so I can add a lowercase I for integer. And there, in doing that, we've just made our three variables compliant with Hungarian notation. You might wonder why we bother doing this, and the reason is because when we start to add more code to our source files, and we start to scroll down further into the source file, we can no longer see the data type that the variable is declared as. So when we encounter the game1 variable here, and it's just written as game1, we do not know instantly whether this is a Boolean data type or not. But if it is prefixed with the letter B, then we can see just from the variable name that this is a Boolean data type. So that's how Hungarian notation can be useful. I'm not using it in the sample projects that we are creating in this course because generally we can easily just see the variable declaration here. But it's a judgment about whether you want to use it in your own projects. You may find it helpful, or alternatively, you may just think that adding these letters just makes the variable names more confusing. That's something for you to decide. So we've coded the main logic for the collection game info class, and now we want to link that to the statue power-up class so that we can figure out when a statue is actually collected in-game. So what I'm going to do is switch back over to the statue power-up class, and let's just scroll down to our touch event here where the statue becomes deactivated. We know that at this point what has happened is that the player has come into contact with the statue power-up and has collected it. And this is the point where we want to update our statue counter. In effect, this is the point when we want to run the statue collected function in the collection game info class. So let's just jump back to the power-up class, and there is a way that we can call that function, and as a matter of fact there is a way we can call any function of the game info class from any actor. So let's have a look at how to do that. So we enter the deactivated state, we play a sound sample, and beneath that what I'm going to do is update the collection counter. Now to do that, we can use the world info class, which is globally accessible to all actor classes. So we have world info.game, and what this variable world info.game, what this member of the world info does is it provides us with access to our game info class, to all of its members, to all of its methods, and all of its variables. Now, we need to do some extra work with this, but this is the variable that we need to access. First, what I need to do is to typecast this to the collection game info class. So we have our collection game info class here. I'm just going to highlight the name of that class, press Ctrl+C on the keyboard to copy it, switch back to the statue power-up class. I'm going to paste that into our source file here and put into brackets here the worldinfo.game. That will typecast the member worldinfo.game to the collection game info class that we have created. After that, I'm just going to call the statue collected function. So statue collected, opening, closing, parenthesis, end the statement there. And in that one statement, what we are able to do is to call the statue collected function of the collection game info class. If I wanted to call a completely different function, all I have to do is keep this statement the same until the period symbol, and then after that symbol I can call any function that I want or access any member that I want. So what I'm doing with this highlighted code here, I'm accessing the worldinfo game member variable, I'm typecasting it to the type of my game info class, in this case collection game info, and then I'm calling whatever member that I want. So in this statement here, we have called the statue collected function when our power-up is collected. I'm going to press Ctrl+S on the keyboard, I'm going to compile this code, and then jump back in the UDK editor to test it. So here I am back in the UDK editor, and I have my DM deck custom level open here, and we can just look around the level and see that everything is as it should be. Now, the first thing I want to do to set this up and running with my game collection class is to choose View and select World Properties from the menu. And here is the World Properties dialog. And for the game type for PIE, that's Play in Editor, I want to select this to my collection game info class, and then I can just close this dialog here. Then I can press Ctrl+Shift+F on the keyboard to display the content browser. I want to switch to the Actor Classes tab, and you can see here My Game Statue Power-Up. We have our statue power-up, and I'm going to drag and drop some versions of these power-ups into the level here. You can see them being added. I'm going to add 3, but remember that we need to add at least 10 if we are going to make this game winnable. So right now with just 3 statues, you can't actually win this game, but just for test purposes, I'm only going to add 3 for the moment. So I'm going to close the Actor Classes dialog here. And so here we have our 3 statues. I'm going to select the first one, press F4 on the keyboard, and in the Properties menu, I'm going to select the rotation speed to 90 degrees per second. I'll select the second statue, set this to 90 degrees per second. Select the third one, set this to 90 degrees per second, so I've set the rotation for all 3 of these statues. Then I'm going to test the level by pressing the play button on the toolbar, like so. Let's wait for my level to compile, and here we have the level open in front of us, and notice that all 3 of our statues are rotating at 90 degrees per second. So what I'm going to do is just run through the first statue, and boom, notice in the console there, statues collected 1. I run through the second, boom, statues collected 2. Notice it's keeping track correctly of the statue collection counter. And I move through the third one, and boom, statue collected 3. Now if I turn around, you will see that all 3 statues have stopped spinning. And notice that if I run back through them, I don't get statues collected. I cannot collect the same statue more than once, and that is because when the statues enter the deactivated state, I can no longer activate the touch event. The touch event is removed from the class as soon as it enters the deactivated state. So that is exactly what we want. We have our 3 statues, and we can only collect each statue once and no more than that. And once we collect the statue, it keeps track of our statue collected counter. So far we've made really good progress, but let's develop our game even further. Now in this section I want to show you the Unreal console. Now this is a feature of the engine that is accessible during a game, and you can access it in any game that you want, in any level. Using the console we can bring up a command prompt and type commands into it. By typing in these commands we can have a look at debug information about the game, statistics about the performance of the game, and we can even use the console to execute functions in our game as well. So I want to show you here how we can use the console to help us create our statue collection game. So what I'm going to do here is just press the play button on the toolbar. I have the DM deck level open, but you can have and use any level to see this functionality. So I'm going to press play on the toolbar to start the level. And so the level begins. Now to bring up the console, I press the tilde key on the keyboard. On a UK keyboard, that is the same key as the @ symbol for writing email addresses. And depending on which part of the world you live in and which sort of keyboard you are using, the position of the tilde key might change. So I recommend searching on the internet to find where the tilde key is on your keyboard. Now to bring up the console, press the tilde key, and you can see here that suddenly the console appears, and at the bottom of the console we have a command prompt where we can type command. Now I'm going to type, for example, the command STAT, which is stat, and as I type this, notice at the bottom that it brings up some suggestions, a kind of code completion dialog here. Suggestions about various commands that we can type in. So for example, I could type in stat FPS, and by pressing enter on the keyboard I launch that command, and I can see on the right hand side the frame rate statistics for our game. I can press the tilde key again to minimize the console, but I still have those FPS statistics here printed in green on the right hand side of the screen, so we can see that our game is currently running at a pretty stable 120 frames per second, and each frame takes about 8.33 milliseconds to calculate on average. Now of course I could bring back the console by pressing the tilde key again and enter in the command STAT and choose memory to see the memory statistics for our game. So press enter on the keyboard, press the tilde key to get rid of that, and straight away you can see we get a whole range of information about the memory statistics for our game. So this is a really neat way we can help debug and view the statistics of our game while it is running. So let's move on with the console. So very soon we're going to be creating our very own console command that we can execute from the console. But before going ahead and doing that, what I wanted to do was take a moment in a web browser to show you a very useful web page. And you can see the address of this page in the address bar here. It is udn.epicgames.com/consolecommands.html, and the name of this page is Unreal Engine 3 Console Commands. You can also access it by searching Google for UDK Console Commands, and what this page does is it lists and describes all the pre-made built-in console commands that are accessible to you in every UnrealScript application. So all of these commands you can just run from the console, and they all do different things. If I just scroll down a little bit here, you can begin to see that we have general commands, and it gives you the name of the command that you have to type and a description of the command. So for example, we have open URL, and we can open a map straight away in the UDK by just typing open and the name of the map. A series of debug commands in this section here, so you can run these commands to debug your games. If I scroll down, you can see even further along here that we have statistics commands. Now we saw some of these previously. For example, you can type stat FPS. You can see that command here, stat FPS. We could type stat game or stat memory, and stat none to just turn off all the statistics displays. So if you want to hide all of the statistic information, you can just type stat none and it hides that data. We can scroll down even further and see even more information. We have memory split, we have all kinds of things for handling the memory. We have display commands, rendering commands. We have all kinds of commands here. Some very useful ones, for example, are those to take screenshots of the game. We have stills and capturing commands. For example, we can type shot to take a screenshot of the display. We have movie capture. We can start recording in-game movies with start movie capture and stop movie capture. That can be very useful for creating gameplay videos. We have gameplay commands, navigation and pathfinding commands, user interface commands, and some very important miscellaneous commands we have get, and we can specify a class name and a property, and it returns the value for that property in that class. We also have the set function, which allows us to specify a class and a property name. It gives us an example here, such as set horn collision radius to a value, and we can actually set the value of variables from the console. So these are some really powerful commands that we can use in our games, and I recommend taking a look at this document when you have an opportunity. So I'm back here in the collection game info class that we have coded, collectiongameinfo.uc, and we have coded this class now so that we have our statue collected function, which is run whenever we collect a statue. What I want to do now is to begin to integrate our code with the Unreal console. And in effect, what I want to be able to do is for us to be able to cheat. And by that I mean I want to be able to run a console command so that I can collect a statue whenever I want. Even if I had a level that was completely empty of all statue actors, I could still be able to run a console command and collect a statue. So the way I want to configure this ability to cheat is effectively to be able to call this statue collected command directly from the Unreal console. I want to be able to say, hey, run this statue collected function from the console and collect a statue. And if I ran that function 10 times, then I would run it enough times to reach our statue limit and effectively complete the game. Now, fortunately for us, UnrealScript comes with a set of features that allows us to convert any function to be an Unreal console command. We can configure absolutely any function so that in one statement from the Unreal console, we can just run and execute that function quite easily. And the way that UnrealScript allows us to do this is by using the exec keyword. So all we have to do is find the function that we want to run from the console, and in this case it is the statue collected function. And in front of that function, I can put the keyword exec for exec. I can press Ctrl S on the keyboard to save this, choose Run from the menu and choose UDK build, and just bring back our compilation window that you can see here. And this analyzes our code, goes ahead and compiles it all. And you notice that straight away I get an error. It's important to remember why we get errors like this, and primarily this is because I have opened the UDK editor. Remember, it's very important to close the UDK editor whenever you compile your code. So I'm going to close this window and just going to close the UDK editor. So now I have closed the UDK editor and I can successfully compile my code, run UDK build. Always good practice to close the UDK editor. Now our script runs away, this time 0 errors and 0 warnings. Our code is now compiled and configured with an exec function. So what I want to do now is jump back into the UDK editor and test out our new console command. So I've jumped back to the UDK editor here, ready to test out our new Unreal console command that we can use to collect statues whenever we want. Now, the first thing I'm going to do is to configure the GameInfo class, just as we have done previously. And we have to do this anytime we want our level to use our GameInfo class. We've seen this before. We select View and World Properties, and for the PIE, the Plain Editor type, just select our Collection Game Info class and close this dialog here. Now I could press Ctrl-Shift-F on the keyboard to display the content browser. I could switch to the Actor Classes tab and begin dragging and dropping our My Game statue power-up actors into the level, but I'm deliberately not going to do that here. The reason is because the console command that we have coded can act as a statue collection mechanism for us. We don't need any power-ups in the level to run our statue collection functionality. We can just launch our console command. Typically the player won't be able to do that, but we have integrated it here because it can be a useful debugging feature for us. So I'm going to close the Actor Classes tab here and just press the play button on the toolbar to launch our game in the editor here. So here we have our game. And I'm going to press the tilde key on the keyboard to open the console. And all we have to do to run our command is simply type the name of the function. So in our case, the name of the function is statue collected. Even here, when I type the word statue, you can see that beneath the command prompt, it prompts us to enter the statue collected function. The name of the function has been built into the list of commands that the console recognizes already, and it did that when we compiled our code. So I'm going to type statue collected and press enter on the keyboard. And when I do that, immediately you can see printed in the console is the response that the function prints, which is statues collected 1. And I can type statue collected again and press enter on the keyboard to show statues collected 2. And I could type it again to display statue collected 3. Now we could go ahead and type in statue collected all the time, but there is a neat way in which you can execute previously run commands, and you can use the up and down arrows on the keyboard to forward and rewind between the commands that you have previously entered. So if I press the up arrow on the keyboard, it gives me the last command that I entered, and I could press the up arrow again to rewind back to the command I ran before that and then before that. So I press the up arrow on the keyboard, enter then on the keyboard, up arrow again, enter, up arrow again, enter, and I can do that to repeatedly enter the command any amount of times. So there we've just got a brief overview of console commands up and running in the UDK editor. Okay, ladies and gentlemen, we have come a long way so far. We have created a game collection info class that keeps track of the main variables of our game, including how many statues we have collected, the number of statues we need to collect, and whether the game is won. We've also created the statue actors here in the level, which we have to collect in order to win the game. If I press the play button on the toolbar, I can run around the level exploring it, and I can collect each of these statues. When I walk through them, they stop spinning, and we have a message printed that tells us how many statues we have collected. These statues stop spinning when collected because they enter a deactivation state, and we coded that using class states. If I press the tilde key on the keyboard here, you can see that I've got the Unreal console, and we even created a console command that allows us to simulate the statue collection behavior. We can just type in the command statue collected, press enter on the keyboard, and there we are. We can collect another statue without our actors even needing to be in the level. But of course our game is not quite completed. There's something else that we need to do to round this off nicely. I'm just going to press the escape button on the keyboard here to exit the play mode. And I'm just going to navigate the camera down to the bottom of the level where we can see we have this bubbling green toxic ooze. Now what I want to happen is when we collect 10 statues, so 10 statues is the number we need to collect to complete the game. When we collect 10 statues, I want an elevator or some sort of animated platform to rise out of this green bubbling ooze. So it begins underneath the ooze, but when we collect enough statues, it's going to come to the surface so that we can jump and step on that platform. And as soon as we step on that platform, we have reached safety, or the goal, the end of the level. Now, to get all of this configured, we're going to need to be using Kismet. We're going to have to use Kismet to create the animation for the platform, and also we need to create a link between Kismet and UnrealScript. When our game is won, we want to trigger that Kismet animation. So we're going to see how to do that next by customizing Unreal Kismet. Okay, so I'm here in the UDK editor, and the first thing that I want to do to get up and running with our animation is to create an elevator platform that rises out of the green ooze, and this will appear when the level is completed. So to get started at this, I'm going to show you the mesh that I'm going to be using for the elevator platform. I'm going to press Ctrl-Shift-F on the keyboard to display the content browser, and you can see the mesh here, SLT Floors SM Floor Ceiling Bridge. You don't have to use this mesh, you can use your own one. So long as you apply physics to it, it should be fine. So I'm going to select this mesh, leave it as it is, just close the content browser and right click on the ooze. and then from the menu I'm going to select Add Interp Actor. That may be just slightly cut out of the recording window, but an option is there, Add Interp Actor. I'm going to select that to add the platform to the level. And you can see it here. I'm just going to bring it over the ooze, and we're just going to position it somewhere near the edge of this platform. This is going to auto-save. So just move it near the edge of the platform and put it beneath the ooze, and I'm just going to leave it at that starting position there. Right-click on the object and ensure that for Set Collision Type that you select Block All to enable collision detection for the object. I'm then going to press the green K on the toolbar to open up Unreal Kismet, and you can see the Kismet sequence here. Now this file, the DM deck level, comes with a range of Kismet data, but I'm going to create my own new sequence. So I'm going to right click on the background, choose New Matinee, like so, and you can see that here. I'm going to double click on Matinee here to open up the animation editor. And in the grey track bar, I'm going to right click and choose New Empty Group, like so. I'm going to name this Elevator and press Enter on the keyboard. Select that track, right click and choose New Movement Track from the list here to create a new movement track. Going to leave all these properties at their defaults, including the starting frame. I'm just going to move to the end of the animation here, press Enter on the keyboard to create a new keyframe, move Matinee out the way, move the Kismet sequence out the way, and just raise the platform up to roughly about there on ground level. And you can see the movement track here visible in the viewport. So that really is all we need to do to create our sequence. I'm just going to close Unreal Matinee here. I'm going to bring back the Kismet sequence. Now just to trigger this animation and see what it looks like, I'm just going to right click in the graph, choose New Event, choose Level Loaded, and from beginning of level I'm just going to drag that connection to the play socket and just minimize Matinee, just move my camera over here, and when I play the level now and I choose play, you will see our platform rises. And there it is, the platform rises straight away. Now it does that when the level is loaded, and if I just bring back the Kismet sequence here, it does this when the level is loaded. I'm going to delete that because we do not want it to happen then. We want this play node to be triggered when all of the statues in the level are collected. And to do that, we're going to use UnrealScript and customize Kismet. So I've jumped back over here to Notepad++, looking at our UnrealScript code, in particular the collection game info class. We've just seen in the UDK editor that we can create an elevated platform using Unreal Kismet. And what I want to happen is for that platform to rise out of a green ooze when the player collects all the statues they need to collect. In particular, if we have a look at the statue collected function here in the collection game info class, you will see that in this conditional statement we check to make sure that the statue counter is greater than or equal to the limit. In this case it will be a limit of 10, and when that happens the game1 variable is set to true. It is at this point that we want the elevator platform to rise so the player can stand on that elevator platform and complete the level. Now we need to set up a connection between this class in UnrealScript and between the Kismet sequence. And to do this, I'm going to need to create a new class, which is a sequence event. This is going to be a new object that will be available in Kismet that we can use. So what I'm going to do is create a new script file. So I'm going to drag in a Windows Explorer window, and I'm going to right click on the background here and choose New, and I'm going to select Text Document. That appears out of the recording window, but I'm going to create a new text document, and I'm just going to name this Collected Event.uc and press Enter on the keyboard. I get this rename dialog appear. I'm just going to select Yes to accept that, and double click this to open this file in Notepad++. This file will contain our new code or class that we're going to use for Unreal Kismet. So I'm back in Notepad++, and now we're inside our collected event.uc file, and what I'm going to do is just paste some code into this file and then explain what the code does. So I'm going to press Ctrl V on the keyboard to paste in this code here, and this represents the complete class that we need to create. you can see that the class name matches the name of the source file, which is collected event, and it extends from the class sequence event, which is a pre-made UnrealScript class that is used as the base class for coding all Kismet events. So when this code is saved and compiled, we will be able to open up Unreal Kismet and drag and drop in a new sequence event module, as we shall see shortly. So here in the default properties block, we just set a few crucial properties. We give it a name, and I've called this event collected event because this event will be fired when the player collects all statues in the level. It's going to be grouped under a category My Events, and this is the name for the menu item that will appear in Kismet. We have empty input links, empty variable links, empty output links. We clear out all the connections and linkages for the module. And here in the output links, we add two links, play and stop. The play event will be the output link that will be fired when our statues are collected. And we have player only set to false, meaning that anything can trigger this event, not just the player. So I'm going to press Ctrl S on the keyboard to save this code, and really the best way to explain this and see how this code works is to look at the effect it has in Kismet. So I'm going to go ahead and compile my code and return to the UDK editor to have a look at the effect that this has had in Kismet. So I'm now back in the UDK editor and in our DM deck level. And you may notice that some of the surfaces in this level do not look quite correct, and that is because when we added our elevator platform to the level, we had to rebuild the light mapping for the level. I have not gone ahead and rebuilt that yet because it takes too much time. I just want to integrate this functionality and see how it works. When we know it is correct, then we can go ahead and rebuild the lighting if we want to. Now, what I want to do is open up Kismet and see the effect that our new sequence event class has had. So I'm going to press the green K button on the toolbar to open Unreal Kismet, and here we can see we've got our Kismet sequence and the matinee sequence for the elevator, and the play connection is still empty because we need to connect it to an event that is appropriate. We have now coded that, so I'm going to right click on the Kismet background, and if I select New Event, you will see we now have an option, My Events, and we have our collected event. This is based on the class that we just coded. So I'm going to select Collected Event and add that to the graph. You can now see we've got this collected event. If I hold down the Control key on the keyboard and click and drag this, we can drag the collected event independently of the matinee event. We have the play and the stop connections. And we know that when our collected event happens, when the statues are all collected, we want the play output to be activated so that it will link to the matinee and play that sequence. So I'm going to drag a connection between the play output connection and the matinee connection here to link these two, so that now our connected event is linked to the matinee event. This setup is correct, although nothing as yet ever fires this collected event. We have got the collected event in the matinee sequence, but we still need to add some UnrealScript code that will actually go ahead and find this collected event, activate it, and ensure that it connects to this matinee sequence. So we're going to be looking at how to do that next. So now I have returned to our collection game info class in Notepad++, and the aim here is to find a way to use this class to activate the Kismet event that we have created. We know that event connects to the play node of the matinee sequence that begins to initiate the elevated platform rising. And we want to kick that in motion, and we're going to do that through the event. But we're going to use the collection game info class to activate the play output connection of that event. We know that here when we check the statue counter and the statue limit and the game1 variable is set to true, this is the place where we want to activate the event. Before I go ahead and do this, I'm going to paste a new function into our collection game info. I'm just going to insert some space along here and press Ctrl V on the keyboard to insert that function. And you can see it here between the opening and closing brace. I've called this function activate event output, and it accepts an index value, which is an integer. 0 refers to the play connection, and 1 refers to the stop connection. If I move over to my collected event here, the 0 connection is play and the 1 connection is stop. We want to activate the play connection because this links to the matinee sequence in the Kismet setup. Now I should just mention that the collected event class will appear in the Kismet graph as a standard node, and that's because it derives from the sequence event class. Absolutely every kind of object that we can add to a Kismet graph represents some form of class. So I'm going back to the collection game info class and having a look at this activate event output. We have a range of local variables that are created here. I'm not going to go into those, but I'm going to examine the functionality that we have. The first thing that this function does is it gets a reference to all the Kismet in the level. So the entire Kismet graph, and it does that by using worldinfo.getGameSequence. Each and every map in the UDK has its own Kismet graph with all of its functionality and nodes and things. And so what we are doing here with worldinfo is we are retrieving a reference to that graph. Then once it gets that graph, it then searches through the graph for an event named collected event, which is the name of our class here. So it searches through our Kismet graph for a collected event node. It then searches through the results because the graph might contain more than one collected event. In our case, it does contain exactly one, so there's no problem there at all. We cycle through all the results. We find the one that we need, in which case is the first one. Here we have the collected event, and we activate the event node. So we say check activate, and we activate that node. So here is the stage where we activate the play output of that node. So just to clarify, we're using the for loop here to cycle through all the collected events in the scene. For this example, we're just using 1, and we come across this check activate function which we fire off on every one of the collected events. This function requires several parameters. First of all, it requires the worldinfo class. We can usually pass that almost always as the first argument. The second argument, which is currently set to none, should be the actor that initiates the event, that causes the event to happen. Since we're firing off a general event here, we can just pass none for that value. The third argument we can just generally leave as false, but critically the last argument, indices, this represents a list of all the connections in the Kismet graph that we want to activate. And in this case, we want to activate the play node, and we're passing that in the argument index. We could, of course, add more connections to the indices list if we wanted to activate more, but in this case, we just want to activate the play node. So we have that then set up, but of course we need to use this code here to activate that Kismet node. So to do that, I'm going to put an opening and closing brace here. And after the game 1 line, all I'm going to do is just activate the output event like so. Paste that beneath game 1. And I'm going to put in a value of 0 because we want to activate the 0 connection, which is the play output. I'm going to press Ctrl S on the keyboard to save this code and then compile it and return to the UDK editor. Okay, so I'm now here in the UDK editor, ready to put everything together to test our game. Now, what I've done here, if we have a look around in the editor, is I've set up a basic level to really test our functionality. I've created 10 unique statues around the level here. So all are going to be spinning. We're going to begin the level here, and we'll be able to run around our level collecting all 10 of these statues. And the final statue is over here. This is statue number 10. And it just so happens that number 10 is standing next to where our elevator platform will rise, so that when we collect the 10th statue, we'll be able to see the elevator in action. Now, before I go ahead and press play on the toolbar, I'm just going to bring up the content browser. When the elevator rises, I want to play this sound to signify that the game has finished. That is UT3 menu start game queue. You can see here I've searched the content browser for UT3 menu start. I'm going to open up Kismet by pressing K on the toolbar. And you can see we have our setup here. Now with the matinee, I'm going to add a new action node that will play the sound cue. So I'm going to right click and choose new action. And from this list, I'm going to choose sound and choose play sound from the list. That may appear just out of the recording window, but I'm going to add a play sound node. I'm going to drag and drop the completed event and connect that to play here. And I'm going to select the sound node. And for the play sound, I'm going to choose the green arrow to load in the selected sound here. The target will be the player, so I'm going to choose new variable and select player and the standard player and connect that to the target. It will be the player who hears the sound. So I'm going to just close the Kismet sequence, move to our starting position in the level, which is over here. And now I'm going to press play on the toolbar to begin our level. So let's just save everything. And suddenly our level begins. So I'm going to collect the first statue, the second one, the third one, the fourth one, the fifth one. And we're going to collect them all. So now on the 9th, I'm going to reach the 10th. And as I do this, ta-da, the elevator platform rises and our sound also plays. So there we have one completed level with all our scripting in place, our statues set up and everything working exactly as it should. Our platform raised only when we collected the 10th statue. So everything here is looking absolutely good. So what I want to do in this final stretch of the course is to show you the awesome power for customizing classes at runtime using config files. Now, to show you what I mean, I'm going to start by bringing up here a Windows Explorer window, and I'm in the UDK game config directory, and you will see in this folder that there are a whole range of .ini files. These files are called config files. I'm just going to open up this file here, which is called udkgame.ini. I'm going to double click that file to open it in Notepad++. And you can see that file here has quite a lot of settings. We can scroll down for quite some way and see all the different settings that are available to us. But I want to draw your attention to this block here. You can see in purple we have the title of the section, which is engine.gameinfo. And this is the home to all of these settings here beneath this title. You can see that beneath these settings there is another title, and this marks the beginning of another section. You will see even in Notepad++ we have the collapsible opening and closing tree view to isolate the different sections. This section is called engine.gameinfo, and that is significant because this section relates to the gameinfo class, which is part of the engine module. And what is actually happening here is that the gameinfo class is reading these default variables. These on the left side here of this statement, we have the name and then the value on the right hand side of the equal sign. On the left hand side is the name of a variable in the gameinfo class. And what the gameinfo class is doing is each time the game runs, it assigns this variable with a matching name this value. And again, the max players variable is assigned the value of 32. Now it's performing all these assignments here in the ini file instead of the default properties block. If I switch over to the collection game info class, you will see that we have three variables here, and they are defined initial values in the default properties block. We have game 1, statue limit, and statue counter. Now, these variables are set initial values here. But if I wanted to change these starting values, I could tweak them here, but then I would have to resave this source file and recompile our code. There is a way in which we can set these starting values from an ini file. And if we do it that way, we can simply tweak the values in the ini file and then just run the game again. we do not need to recompile the code because each time the game plays, the class loads the settings from the INI file. So I'm going to be showing you here how we can tweak our collection game info class to begin to read these values from an INI file instead of from the default properties block. So what I want to do is to configure our collection game info class so that we can read the statute limit from an INI file instead of from the default properties block. If I scroll down to default properties, you see that the statute limit variable is initial value to 10, but I want to be able to control that from an INI file instead. Now, to configure this class to work with an INI file, all I have to do is insert after the UTGame extend statement. I'm going to type config, and here I can put the name of the config file that I want to store these settings in. And I'm going to call this collection game and press Ctrl S on the keyboard to save those changes. Now, we're going to be reading the data from a collection game INI file. So what I'm going to do now is I'm going to jump over to Windows Explorer and create that file. So here I am in Windows Explorer, and I'm going to create our new file. I'm going to right-click and choose New, and I'm going to select Text Document. And I'm going to call this UDK collection game.ini. I'm going to save these changes and then double-click this to open it in Notepad++. Notice if I switch back to the collection game info class that our INI file is named here as collection game. You should prefix the INI file with the acronym UDK. So here it's UDK collection game.ini. And what we need to do now is mimic the standard INI file structure. I'm going to begin a new block here, and I'm going to type the name my game, because in the UDK folder, the directory, we gave this folder the name of my game. If I just bring back the Windows Explorer window, you will see if I go back to the source directory and choose development and source, you will see that at the beginning of this course, I named the folder my game, and that is the name we should match up here in the INI file. So I'm going to minimize Windows Explorer. So it should be my game, that is the name of our module, and then the name of our class whose property we want to set, which is collection game and info. So here we have the collection game info, and I'm going to press Ctrl S to save that. Now I should just mention that what I've written here is entirely in lowercase, and that is because the UDK and UnrealScript generally is case insensitive. That means it doesn't care whether you are using uppercase or lowercase letters. And now we can simply type the name of the variable that we want to set. If I switch back to the collection game info class, you can see that the name we want to set is statute limit. So I'm going to jump back to the collection game info INI file and choose statute limit. And it's going to equal, instead of the value of 10, I'm going to use the starting value of 5. So statute limit equals 5. I'm going to press Ctrl S on the keyboard to save that INI file and just close the game collection info INI file here. So there we have set our initial INI file, but we still have a tweak to perform in the collection game info class. So I'm back here in the collection game info class. The aim is to configure this class so that we can read the statute limit setting, the member variable statute limit, from the INI file collection game. And you can see that in our class declaration, collection game info, we have the statement config, and we're reading values from this config file. And in particular, we want to read this statute limit setting so that we are no longer defining this in the default properties block. In order to set this value successfully from a config file, we have to explicitly mark it as being a member that we read from the config file. And we do that by inserting a keyword between the var and the int of the variable declaration. So between these two words, I'm going to insert the keyword config to indicate that this variable of the class is going to have its default value, its starting value, read from a config file. And I'm going to scroll further down in the collection game info class, And in the default properties block, I'm going to completely remove the assignment here of the statute limit equals 10. We no longer need to set its initial value in the default properties block. Why? Because we will be setting it from the config file. So I'm going to delete that entirely from the default properties block. And now our class is configured, ready to set this statute limit from an INI file, which we can set at runtime as opposed from the default properties block. Now, before I go ahead and compile this code, I'm just going to insert a tick function, which is going to print the statute limit to the console. This is not essential. I'm only inserting this code so that you will be able to see from the console what the value of statute limit is, and you'll be able to confirm that its setting is actually being read from the INI file. So I'm just going to insert some space here and press Ctrl V on the keyboard to insert this tick event here, which is going to print the limit here from the statute limit variable. And this is just so that you can see its starting value is what we have defined in the INI file, which is 5, and is not any other value, that it's actually referencing the INI file. So I'm going to save this code by pressing Ctrl S on the keyboard, and I'm going to compile it by choosing Run and UDK Build, and that runs the compiler. The compiler compiles away here, and we get 0 errors, 0 warnings. Our code is now successfully compiled. So what I suggest we do now is we jump over to the UDK editor and see our code in action. So here I am back in the UDK editor looking at our level, and all I need to do now is, we know that we've set the statute limit property to 5 instead of 10. We set the initial value to that. So all I have to do is press the play button on the toolbar, and when I do this, you can see printed on the left hand side of the screen on each and every frame is limit 5, which is the value that we set in the INI file. Let's just bring up the Windows Explorer window here, and we can see the UDK collection game info. So let's just double click on that INI file to open it in Notepad++, and you can see we have our statute limit equals 5 already set here. Notice that the UDK has also generated a lot of other settings in this file. These settings are all different config properties inherited from ancestor classes. So it's putting in those default values from ancestor classes, which are also marked as config, so as not to break any existing code. Our statute limit is still set to 5. Now, if I wanted to change this value, let's say to 3, and I press save, Ctrl S on the keyboard there. Let's just minimize Notepad++ and minimize Windows Explorer. If I press play again on the UDK editor, you will notice that it still says 5. That is because I need to exit the editor and load it back up again for those changes to take effect. So I'm going to close the editor here, the UDK editor, like so. I'm going to bring back the INI file, collection game info. I'm going to change the statute limit now to, let's say, 3. Press Ctrl S on the keyboard, minimize Notepad++. I'm just going to reload the UDK editor, and I'll see you on the other side of that. So I've now reloaded the UDK editor, and I'm just going to press play on the toolbar. And when I do this, you can see now limit is 3. It's actually reading that setting that we changed, limit equals 3. So if you need to change the INI file, you may typically need to exit the editor to do so, but it won't involve your having to change the original source files and recompile any code. So that is a summary on how you can get up and running with config files. It is a very powerful feature, and I recommend you use it whenever you can. Now, very quickly in closing here, I wanted to address 2 issues. First, you might be wondering what happens if you create a config variable but define an initial value in the default properties block anyway. Well, in this case, the UDK compiler is going to give you a warning, because really, if you're creating config variables, then you should not be defining their initial values in the default properties block. You should be using the INI files to do that. The second issue, the thing that you might be wondering, is what happens if you create a config variable and do not set its initial value in the ini file. In this case, the variable will be set a default value, and for most numbers this will be initialized to the value of 0. But generally speaking, if you're creating config variables, you should be setting their initial values in ini files and not in the default properties block. If you do not adhere to those conventions, then you are asking for headache, and we don't want headache. Well, ladies and gentlemen, we have reached the finale of our course, and it's time to take stock and see what we've covered. We've covered a lot of ground in this course. We have seen how to configure the UDK so that we can compile UnrealScript applications using the tools of UncodeX and Notepad++. And we've also seen how to install the UDK, and we've seen how to configure the different settings to get up and running with our compilation process. We've also seen how to customize the game info class and how to create a Hello World application. And we've also created this application that's in front of us here, which is a statue collection game. We've seen how to customize the game info class to codify the rules of that game. We've also created actors for each of these statue objects that we can collect. And these exhibit state functionality so that they change between an activated and deactivated state depending on whether the player has collected them. There are many other features we've used. For example, we can tweak settings of the game now using config files, and we've also had to customize Unreal Kismet in order to create an animated platform elevator that comes out of the green goo so that we can complete the game. What I want to do just here is look at the ways in which we could expand this project. For example, we could create our own level, our own new meshes and power-ups. We could add sound effects. And there are various ways in which we could use UnrealScript to tweak the behavior of this game even further. We could add enemy characters. And we could also, if we wanted, add a time limit to the game so that the player has to collect these statues in a specified time limit. I'm just going to jump over Notepad++ to give you a brief idea about how you might go about coding that time limit. So I'm back here in Notepad++ in the collection game info class, and I just want to quickly show you how you might go about implementing a time limit. One of the ways you could do this is by adding two new variables to the collection game info class. You might, for example, add var float elapsed time, which will keep track of the amount of time that has passed in the game, and then var float time limit, which specifies the amount of time that the player has to collect the statue. And then all you need to do on the tick event is to increment the elapsed time by the delta time. So it's elapsed time plus equals delta time. That will then keep track of the amount of time that has passed in the game. All you need to do then to check whether the time limit has expired is determine whether the elapsed time is greater than or equal to the time limit, and if it is, then the time has expired. So that is one way you could go about implementing a time limit if you wanted to, but it just so happens for this class that I'm not going to do that. I'm going to leave the time limit out of it, but that's just to show you how you could do that. There are many other ways you could expand this game. You could create a player class that will allow you to customize the player mesh that you use. So all kinds of ways, and I recommend that you take a look at doing them. So that really represents the end of this UnrealScript course, and I hope you really have enjoyed it and got a good foundation and feel for how UnrealScript works and the kind of ways you can go about customizing the behavior of the Unreal Engine. So thank you for joining me. This has been Pact Publishing's Introduction to UnrealScript. My name is Alan Thorne, and I wish you the very best in your UnrealScript adventures.